Anyway, I'm happy to be here. I'm happy for Nicole to add me late to the agenda. And I'm going to speed things up because I have a lot to cover in a short period of time. I don't even have my name on the slide, but this represents work being done by my lab, done with partners like Janet Franklin and others. And it's a whirlwind of stuff that I don't even have anything else on the slide. I was cutting stuff out and I realized I cut too much out. So anyway, a lot of it's been funded by our local partner, Sandag in San Diego, but also with other groups. I'm going to cover a panoply of fire and fauna related stuff that we've been doing in Southern California. I'm not going to focus on larger species like deer, lions, bobcats, and I do want to focus on some of these state changes we're seeing due to wildfires in Southern California. If you go to scmmp.com and look up the fire projects, you can download a bunch of our papers. USGS Army website too, army@usgs.gov, has a lot of our amphibian related work, a lot of which have fire as covariates. And not just my work, but Brian Halstead's work in Northern California on chaparral communities as well. So I'm going to talk with a filter on chaparral communities. Obviously, because it's Chaparral Symposium. The kinds of things we've been considering since the mid-90s, late 90s, when I started working with Zach on controlled burns, where controlled burns was where we kind of cut our teeth going to controlled burns, understanding the direct impacts of controlled burns on animals. Then we switched to catastrophic wildfires, starting in 93, but then mostly after that in 96. And what was driving catastrophic wildfires and how they're having an impact on animal communities. Then we've been focusing a lot on suppression impacts in both chemical use, physical impacts of suppression activities, and then also restoration impacts. What are the kinds of things we do to restore, like let's say the plants, but have an impact on the non-plants. So like I said, a lot of our work is long. I've not spoken at this group before, but we did a lot of engagement starting in 2003 with these larger catastrophic wildfires, 2007, 2009, continuing through bobcat fire most recently, through some of these bigger fires in Southern California that continue. And that's kind of the perspective I'm coming from and how those kinds of things, and I'll talk later about how we get to like now and how we're thinking about fire and faunal impacts. So these different kinds of events have shaped our research program in how we work now directly with the incident command, even in some cases from the initial attack through to the bear process as needed. And so we've been really partnering closely with CAL FIRE and BLM and other fire agencies to help think about how to soften the impacts, but not impacting their ability to do the fire suppression that they need to do. So I'm going to first talk about chaparral, like we've kind of seen in these previous things where there's not landform change, and then I'll talk about landform change tied to fires. And so when I say not landform change, basically you burn the carpet of material over the top, the ground is still in place, and then you can look at recovery kind of in place. And so that's kind of a terrestrial effect. And then I'll look at aquatics next. So 4 of our study sites, we had pre-burn data. So this is a vacuum design. So before and after control impact. The fires of 2003 were the impact. So in some cases we had 2007 as a second impact. And then this first vignette will be kind of these data sets from these 4 sites in Southern California. And based on the new definition of maritime, the Elliott Reserve and Little Cedar would be maritime chaparral, and Rancho Hamul and San Isabel would be non-maritime chaparral, let's call it. Hamul might be a little bit, but and then this is going to be a mix of chaparral and coastal sage-grouse. When we started work in Southern California in 95, when I started my postdoc, it was tied to understanding small terrestrial animal use of the landscape as it linked to habitat conservation plans and the HCP's NCSP program, and how land use planning would have an effect or a benefit to those species in a multi-species concept. I just want to point out, because a lot of this was like, I saw Frank Davis give a talk when I was a grad student at Davis on the GAP program. It was like in the late 80s, and I think I was a high school kid just taking like, seeing, it was early in grad school, but he gave a super inspirational talk on the GAP program, and that drove me to get more invested in this HCP and CCP process as it rolled out. A lot of it based on the early work that Frank had done, so I just wanted to acknowledge that. So these are pitfall traps, snake traps. So there's these drift fences, buckets, and then let me do a time check. And then the drift fences, buckets, and snake traps. This point here. So this is what pre-burn would look like. This is what post-burn looks like. So we've got, in a lot of cases, up to 6 years of pre-burn data, and then we did post-burn monitoring. So we also have, from each site, vegetation transect data. So we know what the habitat was and the composition was before burn, and then we have the post-burn regeneration. And so when we start, this is 2 sites. So this is Little Cedar here, and then that's Elliott. And the community of herpetofauna, reptiles and amphibians, is really different across years at both those sites. Once we have this event, 2003, those come together. And basically, there's a simplification of the herpetofauna, a loss of a lot of functional groups of reptiles and amphibians, and then you get the similarity coming across. So that's looking at 2 sites across all the habitats of those sites. When we pull apart habitats, this is looking across all 4 sites, we can see that the open squares are unburned, and then the closed symbols are burned. And so we stratified all of our post-burn sampling into grassland, woodland, chaparral, coal sage scrub. And you can see that coal sage scrub reptile and amphibian communities are very different than chaparral before the fire events. But then, after the fire events, they simplify and become like grassland unburned sites. And so that change is a community level change in the reptiles and amphibians. And that's what we want to understand is, how long does that change take to recover? And a lot of our work has been looking at that recovery of that change. And then this is now just showing you how the habitats have changed. So the darker purple are early veg transects, and the darker red are more recent. So this data goes through 2012, and that's our post-burn. It goes through 2012, and you can see that there's a simplification. Sorry, not a simplification, but a change from, like in chaparral, native scrub is pulling that way, and open ground is pulling down there, and non-native grass is pulling here. And so you can see there's a shift in both of these communities, both TSS and chaparral, away from that historic, and not a recovery back to the historic, at least within this 9-year period after these fires. So then the winners and losers. So I'm gonna just jump through some taxa real quick. I have till 10:15, right? Okay. So these are amphibians. So losers from fires would be this side, winners would be this side. For amphibians, there's no actual winners. Maybe Spadefoot likes it a little bit. I'm going to jump through, and this is how the community structure is changing then. So then here's lizards. So side blocks lizards, winners. A lot of other things, losers, like alligator lizards. So things that are more mesic or northern species that are at the southern end of the range in Southern California, are typically the losers. And things that have wide distributions in the desert and come into California, or typically into coastal California, are typically the winners. So they like that xeric non-habitat situation. So then here's small mammals, shrews, which are northern type species, losers. Neotoma fusippes, wood rats that build big mounds, losers. Wood rats, like desert wood rat, winner. And then things like Dipodomys similans, winners. And so you can really see how the community pulls apart with these events across these different kinds of taxa. And so it kind of generally looks like this. You get a pattern of, on the left, of what happens with capture rates pre-fire and then post-fire, and then what happens with capture rates post-fire is much better than pre-fire. And so we get this transition for a more xeric ecosystem. And our question has been, how long does that take to recovery? More than 9 years, I'll tell you that. Because we had to transition our research program to drought and eagles. And we never got to continue kind of do this work. And so we want to get back to this work at some point to see if we've got this recovery. So as we talk about fire on the landscape, 5 minutes, perfect. Fire on the landscape, I'm transitioning to some other studies we just published the last 2 years. We talk about, this is from Will Madrigal from last week at the Trilateral meeting. He talks about good fire, and that's the tribal use of fire. And we talked a lot about that yesterday. And so there's 2 examples of where tribal use of fire possibly enhance these species at Camp Pendleton. I'm going to talk about 2 studies from Camp Pendleton. And then here is Dipodomys stevensi. It's a federally threatened species. And you can see its occupancy and site colonization probability go down as the fire return interval gets longer. So basically, these things need frequent fire to manage the non-native grasses on the landscape, or to try to enhance the foreland, so it doesn't transition into scrub land, basically. And that's probably was from what we talked about Crespi yesterday, where it was fields of forelands and grasslands that's been transitioning because we've been pulling fire off the landscape. And so this Stevens kangaroo rat and then this one, Pacific pocket mouse, both show that same pattern at Camp Pendleton, where one is real coastal, one's inland on base, but they're both have a super negative effect of longer term return intervals between fires, and that's probably tied to that indigenous use of fires in those coastal landscapes. And then this is a paper that's going to be coming out by Barb Coos, where she shows the opposite pattern in gnatcatchers, where basically gnatcatchers take decades to recover from fire events. And so this is showing occupancy as highest in the oldest unburned areas for gnatcatchers. So now I want to transition to fire in aquatic systems, and this is now where you do have geomorphic change in some cases. And so like I said, we started in 2003, fires, going to sites and seeing that things were gone when we showed up the next spring. So then in 2007, we got closer to the actual fire event, and we were still seeing species were missing. And then in 2009, we started being in active fire events, being in the station fire while it's still burning. I spent 5 weeks there, and looking at things disappear from the landscape in a real time. And so, real quick, Arroyo toads, what we found is another endangered species in Southern California. Is a year since fire really has an effect on it. So like fire opens up its landscape through geomorphic change. Basically, they're sloughing off the hillsides, and then creeks that are overgrown, like on the right bottom, become these alluvial washes, and then that recovers the habitat. So that one is a winner from fire. But dry ravel is the mechanism we still started to focus on. So flourishing, this paper from 91 is great. Basically, you remove organic material from the slope, and then that inorganic material stored behind it in chaparral systems falls into the channel. Here's what that looks like real time. I'm going to jump ahead because I'm running out of time. Let me see if I can play this. I want to play my video. I don't know where the mouse is. There we go. I said I have an old school. Okay, I don't know if I'll be able to play the video, but this is. Try. Yeah, try. It's fun. Okay.
Oh, okay, sorry.
It's not. It won't do it.
Nope.
All right. Sorry. So this is. I'm standing inside an active fire. This is a chaparral hillside, and the hillside is sloughing into the creek real time, and so that's called dry ravel. That's the mechanism that Florsheim describes. This is that same site in June of 07 with native rainbow trout stock that are steelhead origin. This is during the fire in 07 as it's sloughing down the canyon. And then here's that pool that's filled in without any rain being added. 2 minute warning, perfect. Because my video didn't work, so I'm on time. We're watching real-time extinction events happening in these aquatic systems. This one probably won't work either. And then this is basically debris flow from the Waterman Canyon thing. So basically we're seeing extinction extirpation events from without rain, and then when you add rain to these systems, we're seeing entire system collapse. Then when we add humans to the landscape and we add chemistry, we see the geochemical responses that have an effect then also on animals. And so this is The circles are different kinds of ash, and this is just a simple pH of leachate example, looking at it. And so pH of leachate goes way up, especially residential, but this wildland white ash is the lightest ash that blows off typically right away, and blows off, gets into creeks, and that's the one that's gonna basically fry animals that are left in the creeks when you get ash in the water. And so basically we're filling in pools, we're burning things. Lots of ways to kill animals in chaparral fires in the aquatic systems. Again, you're seeing these die-offs of fishes. While the fire is still active, before, if we came back in spring, we would just see no fish. Here we're actually seeing the die-offs. And then this was an early compilation of how many populations of extirpated or declines we had seen in Southern California. This is like 10 years out of date. But it's really bad for T&E species in Southern California from chaparral fires in these mountain landscapes in particular, where you have geomorphic change tied to the fire. And then, oh wow, that was super fancy. Those were not the slides I was going to show. The other thing is when you look at the genomics of some of these wetland species, like this red-legged frog within these burn footprints of what's left, we're seeing major impacts on bottlenecking. We're seeing NE, effective population sizes drop. And so as we're going through these burn cycles, we're then continuing to degrade the genetic integrity of a lot of these species that haven't actually gone extinct at these sites. And so basically the next steps, continue to identify burn refugia sites for trust species within conservation lands, work with pre-burn management strategies to reduce burn intensity and damage from wildfires, revisit recovery times, from the 03-07 fires to see if anything's gotten back to before, and then understand all the long-term impacts of lower genetic diversity via bottlenecking on small populations driven by wildfires. Thanks, you guys.